Welcome everybody. We have opened the webinar. We wait a few minutes for everybody to give them some time to listen in and to access. Good afternoon to all attendees. My name is Leon de Ridder. I am the Sales Director of Cisper, and it is my pleasure to host this collaborative presentation from Senstis and Cisper. Next slide, Neil. So the aim of this webinar is to inform you about the possibilities of passive sensor technology based on UHF RFID. It is just to get you introduced to the technology and the possibilities. This presentation will be done by Neil Mitchell mainly, and I will help him a little bit. So Neil is from Senstis, an American-based company with quite an extensive experience in passive sensor technology. If you have any questions during the webinar, please write them in the question mark box in the right top corner of your screen. Next slide, please, Neil. So before Neil starts the presentation, I would like to share some of Cisper's company values with you. We want you to know that we are a 100% distributor, which means that we are not offering solutions to end users. We will not be in the way of our system integrator partners. Our focus is mainly on passive UHF RFID. Hence, this presentation is in line with what we are doing. We are transparent towards our customers, first of all, and that means that we share supplier contacts with them. We don't try to hide anything. And in contrary, also to suppliers, meaning that we share POS information of what we sell to our customers with them. We believe that bringing together people in this market is one of our specialties because we believe in cooperative success. Okay, thank you very much so far. From now, Neil will take over.
Well, welcome everyone and good afternoon. So just real quick, just about Senstis. We've been around about 8 years now. We started out pretty much as an RFID hardware organization, but since then we progressed into providing software services, engineering services basically, and ended up specializing in these passive sensors. We were originally pulled in by a very large inlay company, and they needed some help in getting some of these passive sensors into customers, and these are not the normal commodities part, and they do take some engineering. So they called us, and that's really pulled us into this technology, and we've been involved ever since. So I think we have a poll.
Yeah, so to start with and to engage everyone, we have some questions for you to answer. This is number one, we have two. Our first question is why you are attending this webinar, or what the main reason is for you to attend. So take your time and make your choice. it is good to see that some people just want to see my face again.
There's no accounting for taste, Leon. I'm sorry.
There's no account. No, it's sorry. So thank you very much for answering. The floor is yours, Neil.
Absolutely. So let's talk about what an ideal passive sensor really is. And I'm aware that part of the audience here is going to be RFID folk, but part of the audience are also going to be unaware of RFID, are not familiar with it. So for those that are not familiar with this technology, this is actually amazing. This is a wireless, batteryless technology that can sense the environment and provide information about the environment. For RFID folks, probably aware how RFID work, but again, we're helping our partners bring this technology to market that can detect all the different capabilities that these sensors are and bringing them into the market. So yeah, it's also novel because there's no maintenance involved, because there's no batteries, and they're just very, very different from a traditional sensor, which is wired. They're expensive. They'll be connected to a hub. That hub's expensive. You can have maybe 4 sensors connected to a hub, or maybe 8 if you're lucky. By the time you cost these things out, they're very, very expensive solutions. But now with these passive sensors, because they can be applied, they're very thin, they can be applied to all kinds of products, materials, even inside of certain materials. That they can provide a sense of visibility into what's going on inside a manufacturing process, for example, or in a certain environment that previously sensors were not capable of doing. And one of the key points here is also that this is just a different world of economics. A lot of traditional sensors are $50, $100, $150. These passive sensors are about $5, $1, depending on what it is and the volume that you're buying these things. So it's a very, very different ball game to traditional sensors. So what can these sensors measure? Well, this slide gives you a sense of that. So the interesting thing is most of these passive sensors actually report 2 things at the same time. Most of them actually report temperature and then one other thing. And there's a sensor code on these passive sensors that will report either moisture, relative humidity, strain, or index of refraction. And basically with some engineering work, which we do, we're able to interpret some of the basic capabilities like moisture that these sensors do, and are able to use that data to interpret different things in the environment. And you'll see that in a couple of slides' time. So even though there's a list of 6 items on the slide here, the reality is what we can detect and measure and report in real time with these sensors is actually effectively larger than what you see here. It's also important, and again for RFID folk, this is maybe old hat, but each of these sensors has a unique identification. In the RFID space, we call that an EPC, but again, that is useful in the terms of sensors because it allows you to tie an ID to a particular location on an item that you want to measure temperature on, for example. So maybe you have a large object and you have 3 of these sensors, and the ID will tell you where that sensor is on that item, and that gives you the capability to provide additional sense of what's going on to that whole particular product or thing that you're tracking and tracking temperature on. So again, for those that are less familiar with RFID, this is how these passive sensors work. So we see some examples of these passive sensors here. These sensors do come in, we call them almost like a label form, as you can see here. But they can also come on a small printed circuit board as well, as you see in the image here. And these, because there's no batteries, they have to have a potential difference created across them. And that potential difference is created by RF radiation, which is transmitted from an antenna about 20 feet, 30 feet, up to 3 or 4 meters away. And those antennae are also connected to a reader, which is sending the appropriate protocol to ask these sensors to return their information. The information is returned from these sensors by, it's called backscatter radiation, but basically these sensors are reflecting the RF radiation back. It's modulating it with the information that's needed to be understood by the reader. So its ID, the temperature, the moisture, or whatever it is, or strain that's being measured by that particular sensor. So the other very novel thing about these sensors for sensor people is, as I alluded to earlier on, these traditional sensors that are wired, use 5 or 10 or a fairly small number of them. But with this technology, we can have hundreds, thousands of these sensors being read, in quote, simultaneously, so in a very short amount of time, from just 1 or 2 antenna. And so there's many to one relationship that, or very many to one relationship that really doesn't exist in the traditional sensor market. So some examples, temperature tracking is perhaps the most obvious one. And there's a variety of different applications we've been involved in temperature tracking. You're looking here for anything where you're concerned about temperature being out of spec, whether that's too low or too high. Obviously, there could be foodstuffs, it could be materials that need to be kept in a freezer in an industrial environment. We'll touch on that a little bit later. It could be electrical equipment, transformers. Transformers clearly need to be operating in a certain specification. Motors and other critical infrastructure. So here we can report on things getting out of spec. Something's got over 100 centigrade or 50 centigrade, and we can report on that. The moisture and leak detection, and in fact here there's actually 2 sensors that can be used in these kinds of applications. One is for moisture sensing. So that's actually sensing drops of liquid effectively, and maybe very, very small drops of liquid, or pulling up moisture from a certain part of a product, and we can wick it up to the sensor and detect that moisture. And then that's on one hand, and on the other hand, there's actually relative humidity, which is basically moisture in the air. So those are 2 different sensors, but those both do exist. So there's a lot of applications for leak detection, whether it's commercial air conditioning systems, whether it's these huge pieces of electrical equipment which are use oil to keep them cool, and if that oil leaks, it's a big deal. So detecting those leaks is really, really important. Seal failure. So detecting that seal failure is obviously critical. So we can certainly do that with these sensors. One I kind of touched on a little bit earlier was strain. So literally we can detect the kind of the pushing and pulling or twisting of an item by applying one of these sensors. So for example, we can apply them to a helicopter blade, and as the blade is rotating, we can detect that effectively stress on the material. The other thing that we can do with a strain sensor is we're actually doing this right now for a government contract. We can effectively detect vibration. Vibration is just change of strain over time. So if the strain is going up and down, effectively that's vibration. So we can detect that pretty quickly. Right now we're detecting 10, 20, 40, maybe 50 hertz type vibration and reporting on that. And we have things in play with our partners to get that up to hundreds of hertz. And so that's very useful in military equipment, clearly. Detecting when a failure is potentially going to happen, and if you're in a helicopter, getting that helicopter down quickly is a good deal. One of the applications that we've done a lot of, and we've been pulled into by several folk, is that we've been requested to help companies with very large, effectively fiberglass structures, such as wind turbine blades, to monitor the blades during the manufacturing process. They've had some pretty big quality problems historically in this industry. And so one of the problems they've had is they've not been able to literally look inside of the material of the wind turbine blade as the blade is curing. And so with these sensors, we can actually put these sensors actually all the way down the mold, or we can literally put them in between the layers of fiberglass during the construction of the blade or the object. And then we can, in real time, report, because we can detect effectively the index of refraction and the density of the material, we can actually detect when resin has arrived at a certain sensor. And of course, with tens or hundreds of sensors, we can effectively produce a 3D map of where the resin is in a structure. And we can also detect the all-important, it's called glass transition point, when the material, the resin starts to cross-link and turn from a liquid into, starts out as like a honey liquid, into something which is basically a solid. And we can monitor the curing of that solid material over time as well, until the point where, okay, it's cured enough, now you can open the mold and move on to the next one. So we're helping these folk massively optimize their production, so it's less wasteful on resin material, for example, optimize on time, but also it's allowing them to increase their quality dramatically as well. I should also state that the sensors can actually either be left in the blades, or they can be taken out if they're just left on the mold and replaced, so that the sensors can optionally be left on the blade for use outside of the manufacturing process, either tracking or maintenance later. So we could leave a strain sensor in, and that could be read 2 years after it's been installed, and we can actually measure the strain on that blade to see if it's still good. So this is an example of the type of data we actually get out of a single sensor in this case. So you can imagine if you've got hundreds of these sensors, you get this kind of information out of hundreds of sensors, what kind of 3D image you kind of get of the item that you're measuring. But as you can see here, this is literally a screen capture from our software. So the orange line here is the sensor code, and the sensor code in this particular sensor is effectively it was designed to measure moisture, but in this case it's actually measuring we've used it to measure the density of the material and the refractive index of the material. And so you can see here that time zero, there's basically no resin at this particular sensor, and we see this big jump up here when the resin arrives, and then the resin starts its cure process. And it's an exothermic reaction. So the blue line here is temperature. So the temperature starts to increase during that process. And this phase transition here, this is when the cross-linking happens and the glass transition point happens. So at this point, this is where the resin's starting to cure. And we can track all of this over time. And once this reaches an asymptote, we know that the object has cured, the resin's cured. So again, this is the type of information we can provide. There's other applications. Concrete's another one. Interestingly, concrete effectively is another composite material. It's just composite of concrete and rebar. So it's just a different type of composite material. But again, we can measure the curing on this. It's a different type of process because it's actually called hydration, interestingly. So when concrete cures, it's all about keeping it as wet as possible. And a curing process requires water, but it is also an exothermic reaction. It basically increases in temperature. And you can kind of see this in the chart here. You can see that in this case, the temperature is increasing here. And here we see the when we apply water, you can see the water, the hydration basically going up and down as the water gets used in the hydration process. So again, this is the type of information we can deliver to help people optimize their curing process. Taking this one step further, we've also been working with some companies that effectively want to create smart building materials. So, for example, the kind of gypsum board that would be in a flat roof on an industrial or commercial building. We've been embedding these sensors inside of those materials during the manufacturing of them. So, a large board of, ceiling board would have 3 of these sensors in. These are all installed in a roof, and then basically run a little robot or a cart over the top of the roof, and we're reading those sensors in real time, and we can report on the moisture content of that sensor, and obviously if there's a leak there in the roof. And in fact, when we first did the prototype of this, we stuck it up on a building of the company we were working with, and we found 3 leaks for them in their roof they didn't know about, so we were pretty happy. And also we worked with the company in Singapore. They were concerned about, in Singapore it's very hot and humid, so they're very worried about moisture and water ingress getting into some of their utility buildings. So we've helped them there with some of their applications. There's a bunch of others. I'm not going to go into all of them, but pharmaceuticals is a big one, tracking the temperature and obviously getting water into some of these things is a problem. So that's important. Another interesting one is pipes for petroleum. So we are already working with organizations to detect leaks in petroleum pipelines. And the problem we're solving for them is traditionally companies can tell when there's a leak in their pipeline because they can tell by pressure and some other things. And they know roughly that it's between mile 7.5 and mile 8.25. But they don't know exactly where to put the shovel. So with this technology, they're putting sensors in every few meters, and we can actually tell them, within those few meters exactly where to start digging because there's a leak at mile 8, and they need to dig literally right here to go and find that leak and fix it. Pre-preg out time, for those that are involved in kind of fiberglass and carbon fiber materials, carbon fiber in particular. Pre-preg materials is basically a name given to these materials that are composite materials that already have the resin impregnated. So effectively start drying immediately, but you stick them in the freezer so they don't, and then you pull them out when you need them. So actually tracking when these things come out of the freezer is very important. So again, we can use this technology for effectively tracking the accelerated life or aging of materials as they come in and out of the freezer. So with that, over to Leon for the second poll.
Yes, thank you very much, Neil, for your clear presentation on this technology. And now our second and last poll with the question, what did you learn today? What was most important for you? Okay. We see that a lot of people think that it might be useful technology, and also people want to have more information. Well, that is something that we will do in a next phase. We will have a follow-up webinar with more content about the technology itself and how it works and some major applications. So thank you very much. So did we provide you valuable insight? Probably yes. If you have questions, please write them in that question mark square on the right top corner of your screen. And Neil will get some questions answered right now.
Okay, is there a reading range performance of the RFID sensors? So the sensors the thing with RF radiation generally is that it depends on the environment. Is the easy rather flippant response, but effectively we normally say this technology can work from about 20 to 30 feet away. With these passive sensors, it might be just a little bit less than that. So we're normally talking of between say 3 and 6 meters away is a good read distance for some of these sensors. Um, what's the maximum data rate? That's an interesting question. Perhaps a different way to answer that is we're not limited by data rates. The data actually coming from these sensors is low data rate, but it's how quickly can we read the sensors. We can access these RFID devices basically maybe up to 1,000 times a second or so, or 2,000 times a second maybe. There's some nuances associated with that, where the actual read rate you get is actually less than that out of the sensors. But if you kind of assume 100 times a second for these sensors, you can read 100 sensors, or you can read one sensor 100 times a second. That'll give you kind of a flavor for the type of data you can get out of these things, and that will only improve over time as well. Let's see.
One more,
That's
maybe.
true. Sorry, Gil.
Yeah, one more question, maybe, if you have one. Or maybe more.
Yeah, there's quite a few here. Okay, someone's interested in learning more about the pharmaceutical application, so we can certainly follow up with you after that. Another one is can the sensors log data over time? And the answer is that you kind of can. There's not much data or memory availability on the sensors themselves. There's a little bit. You can actually do a little bit of logging there, but not much. But yes, you can log the data, but the logging is actually done in what's called the reader. So the passive sensors, they're accessed and the data is pulled from them, and that's all stored in the reader, which does have memory. And so effectively, as long as the sensor is within the range of an RFID antenna, then you can log the data in the reader. It's not a battery device, so if the sensor is too far away from a reader and is not being energized by that reader, then you won't get data from it and you won't be able to log the data. Okay.
So the rest of the questions may be offline after the webinar. Or if you want to have another one answered, Neil, please go ahead. We have time.
Yeah, there's another question here. Just trying to find the whole question here. Who are the main manufacturers of these sensors? So that's complicated to answer because there's the IC guys who make these sensors, and then there's the inlay guys who make the antenna and the structure that the semiconductor component goes onto. Those then have to be converted into something which is usable by you. So the answer, there's quite a few different answers down that little pipeline, but if you'd like to reach out to us afterwards, we'll be happy to talk you through that, because there's a lot of different people involved, and that's why people come to people like Cisper and us. We can just simplify that for you and just walk you through it. And what we bring to the game is the knowledge about how these things work, the different partners. We can look at an application and then tell you, hey, look, you probably want to use this type of sensor and therefore this type of vendor.
Okay, thank you very much, Neil. Thank you to all the attendees of today's webinar. We will share this recording to all the attendees in a later phase, and we'll hope to welcome you back in our follow-up session. Thank you very much.
Thanks, everyone.
Bye-bye.